I'm going to show you today what Hugging Face is all about and the opportunities for you all. So as you know about GitHub, potentially you have the opportunity to build your own portfolio for projects, neural networks, and stuff like that. And Hugging Face allows you to do that as well. So you can create additional kind of a place for your projects right in the Hugging space. And Hugging Face space. I know it's a bit difficult, but yeah, so you can right there create your projects that can be shared directly for your team and with your potential employers. So that's something that's added value. And for every lab, I want to build a small project. Not today. Today is just a brief introduction. So from the next lab onwards, we're gonna build more and more complex projects together. So you can build a decent portfolio of projects that can help you achieve whatever you want to achieve. Get a new job, be promoted, build your own startup, whatever is all about today's AI. Okay. I'm going to share my screen right now. The template that I have today is in Google Colab. Google Colab is online editor that allows you to basically write code as a Jupyter notebook right in your browser. And I sent you this link. So this is a template. And when you go there, click File, save a copy in the drive, and that's going to create a copy, and it's going to create a completely new file that's directly your personal file, copy of this template. So you can edit, save, and stuff like that, and it will be saved. If you start editing right here, it will be you will be able to edit. However, you won't be able to save. So once you close this browser, unfortunately, all your work won't be saved. So make sure to create a copy of this template so you can follow along and get your stuff saved. Okay, so here is the Hugging Face. When you go and just look at for a Hugging Face on Google, the first site that will pop up is Hugging Face, the AI community. Now, they call it a community. However, in a nutshell, it's a Python library, and not only any Python library that allows you to build crazy, amazing stuff with AI with just a simple couple of lines of code. And amazingly, there are so many models. We are going to explore some of them today that are right in there. So, for example, for models, see how many models we have. Let me zoom in. So, image to text to text. I don't know what that means, but I know. But visual question answering, then document question answering. For computer vision, see how many tasks you have. Depth estimation, image classification, object detection, every single image to 3D. All of the stuff that you can think about AI, you can build with Hugging Face. Now, even for robotics here, as you can see, we're going to explore some work with text, potential images today, but in a nutshell, you can do whatever you want. You can even build like a small model of self-driving car right using Hugging Face. Now, I'll come back to the models in a bit. You have data sets as well. So data sets, the same granularity level. So for example, depth estimation, and you will have a lot of data sets that you can download and train your own models, as you can see right here. So it's a data set, and you can download this data set and start working with it. So it's a kind of a Kaggle for data sets, and the models are really powerful models. And you will see that there are so many great companies pushing models like Google here. Gemma is open source model by Google. Then you have Mistral. You have all the all the greatest models that we can think about them today right here in this platform, and we can easily just plug and play some of them and start using them. Now, of course, we need decent GPUs, and we're going to talk about that today. For example, Meta Llama, this one, it's a Llama model, and in most cases, you will see that here I can say, hey, how are you doing? Now, for this model in particular, I need a pro subscription to get to use it. But for most models, let's say text classification, and use any of the other models, I can log in with my account. Okay. I'll log in a bit. If you want to explore right here more powerful models, you will get basically this. So this model in particular labels anything negative, natural, or positive. Okay. And we're going to start using that right now. Let me see if there are many questions. Not yet. Cool. So this is kind of at the goal of Hugging Face, making usable, powerful models right there for you. So let's start immediately working with it and see how to get to know how to work with it. I provided a couple of links here for documents and full course of Hugging Face. Now we're gonna cover all of that in the next couple of live labs like this one. But if you don't want to wait, there are many great materials out there. And as I said, it's a Python library. Now, in most cases, people used libraries such as PyTorch or TensorFlow to build their own, let's say, CNN, which is for recognizing computer images. And it looks something like this. Now, it's not as complex as somebody will think. You don't have to worry about this right now. And this is a simple neural network. Now, and most people don't really know, never work with neural networks, never got to train their own neural networks, which is fine. But with Hugging Face, we don't have to, because most of them that is abstracted to the one line of code. So you can just import that model and just use it. If you want to train it, now there is obviously the choices for that. We're going to train our model today as well, but that's basically what Hugging Face allows. Before we start working with anything, you need to use GPU, because all of the computation that we're going to use, you can perform on CPU, but it's going to be really slow. So in most cases, it's much better to get to your GPU. Google Colab allows you to use free GPU when you go to Edit, Notebook Settings, and here you have GPUs. I'm using Pro version of Google Colab, so you will have maybe T4 GPU or something like that. I have all of them available, but I'm going to use T4 because most of us will have T4 for free. So you don't have to pay any money to Google to use their T4 GPUs for free. Click Save, and here you will see Connect to T4. Let's connect together. It's going to take a couple of seconds, and while that happens, let me check the comment section. Okay. For now, you don't have any questions. Please let me know if you have. Okay. So now that I'm online, the first step is to install two libraries. One is called Transformers, which is the name of Hugging Face library, and the second one is datasets. So write pip install transformers, and I'm gonna copy this line and paste it below and write datasets. sets. Okay, cool. Execute this cell. And depends on the version of Google Colab. Sometimes something is already installed, something is not installed, but better make sure that everything is up to date. Then we have some differences in the code version. Once you do that, you need to import some libraries. So here, the first library that I'm going to import is collections. From collections, import default dict and counter. Now, most of these libraries might not be as useful as maybe some of them we won't use today, but just to import them right now, nothing spectacular. We're going to import them and potentially use them in a bit. And I'm going to import JSON for some data. And here I'm going to import NumPy and import Torch. So I'm importing Torch because Hugging Face works both on Torch and TensorFlow. So to make sure that it actually gets to Torch and not to TensorFlow, I'm importing Torch just in case, because sometimes Google and our local machines might screw up the versions of libraries, and I don't want that to happen. Okay, so let's check if everybody done this. Have you guys done this? Imported all libraries, so we can continue with the first step. Okay, cool. So the next step is to define something called pipelines. And before I do that in the code, I want to show you right from their documentation. So pipeline is Hugging Face pipeline. You don't have to type this. I just want to demonstrate this. So every time we use some, let's say, text processing, text classification model, something like that. Like whenever you write something in ChatGPT, you have a couple of steps, and I'm going to explore and explain today all of those steps in more detail. But you will see that in most cases, in most let's say advanced cases, you need to define the first step and the second step. The first step is called tokenization. And don't worry if you never heard about this term. I'm going to explain that in a second. And the second step is obviously prediction or making some text processing happening. Whether or not it's generating more text, classifying if that text is positive, negative, or whatever, or something different. But in all the cases, whenever we work with text, the first step is to work and tokenize it. So what is tokenization is this. So you will have like this. I love this car. And for us humans, I love this car is just a normal sentence. It doesn't have anything weird inside of it. However, for computer, it doesn't know how to work with it, because for computers, we need to use real numbers to make some computation. So in this, instead of using characters as we humans love to do, computers will need to convert these into some kind of numbers. So maybe I will be 100, love will be 400 or 43, this will be 444, and car will be 10 or 11. And then maybe you have exclamation mark as 3. So what happens here is you have something called vocabulary. And vocabulary is nothing else but, let me, oops. Let me do this here. Okay, so vocabulary, just a list of words that we know. All of us in this call, we have a limited amount of words that we actually use and know. A lot of words from Serbian or English or German, I don't really know. Never used them, never read about them. It's not in my vocabulary. The same goes for computers. So basically, we will have dot mapping to 0. Then you will have maybe a question mark mapping to 1, exclamation mark mapping, exclamation mark mapping to 3, then dot dot dot. Then you will have love, that is going to be 43. Before that, you will have car, that is mapped to 11. Okay, so any word that we know is processed in a way that we know what order we put it in this row. That's it. What this is the index, basically 0, 1, sorry, this is 2, and stuff like that. Okay, so that is something called vocabulary. And when I um, when I convert this text into something we call tokens, it's the simplest version of that is basically telling this huge vocabulary. This huge vocabulary inside of, let's say, ChatGPT is thousands and thousands of unique words. And whenever I map this, it's gonna ask, okay, what is the index in this huge array? And then change to that index. And that's it. That's called tokenization. Okay, cool, Oleg, thanks. So this is basically the process of mapping the text to something that computers might understand. Now, when we start building more sophisticated, let's say, solutions right here, let's start with the pipeline. So the first step is to go and do from transformers import pipeline. Okay, I'm going to create a new cell while this happens. And here I'm going to define something called pipe. You can define whatever you want. It's just a variable. And this pipeline is going to take just a single argument, which is the name of pipeline that we want. And here are all the versions that we like. Now, sentiment analysis is something that I like to start with. But then here, feature extraction is something that generates these tokens for us. Fill mask is basically we write a sentence and then mask one word and say fill it in, and then it fills and changes that word. Let's say we write something like I mask this car, and then computer will figure out what word comes here, basically like that. Then you have NER, NER, which is name entity recognition. This is a subject, this would be an object, and this stuff like that. Okay, then you have summarization, basically summarizes the text. Translation translates the text. Zero shot classification is basically you put one single example and say, hey, here is my sentence, I want this to be positive, and it's going to figure it out by your example. And we're going to explore with those in a bit. However, sentiment analysis is the easiest one there. It basically tells us whether or not whatever we wrote is positive, negative, or neutral. And look at this. To make a prediction, we just put whatever we want inside of this. I hate drinking this tea. Label negative. So this is basically, and see how fast it is? And I didn't do anything. It's 2 lines of code. And you are just working with 2 lines of code and you're getting this thing. Okay? So if I say I hate that this tea is so good, good, it becomes positive. Okay? If we say so normal, it becomes negative. Okay? I am okay with this t being so normal, it becomes positive. Okay, so with a single line of code, suddenly you have an option to go and achieve something like this. Okay, are you following, guys? Nice. All good so far. Have you managed to make your first prediction with Hugging Face? Okay. So let's switch this into some other pipeline and use, for example, NER, named entity recognition. To do that, you just use this and paste it here instead of sentiment analysis. And it will download the model for us. It will take like a 5 seconds. It's nothing wow. And I'm going to use the same sentence. Okay. So let's use this, execute this sentence as well. Okay. And okay, I love this car, and it doesn't make predictions. So this is not expected because it's using some model that requires more work. And that's what we're gonna do right now. So let's go to their documentation and figure it out. So NER, okay, cool. So you can build tokenizers like this, and we're gonna do that in a bit. Okay, so if you can't build something with a pipeline, or it requires more work, as you saw from the documentation, that's where your kind of a additional knowledge about these pipelines and additional knowledge about the Hugging Face as a whole comes into play. And you will see it doesn't get much harder. It requires 4 more lines of code, but in general, that's it. So the next step is basically to achieve something like this. We need to import from transformers import auto tokenizer. Okay, and just follow along right now, and then I'm going to explain each of them. And the second one is going to be auto model for sequence classification. You see how many of the models you have. For us, we need sequence classification because let's say we worked with positive or negative sentiment. Execute this, and you have everything here. Okay. So now let me explain what are these two. Auto tokenizer is a model that allows us to basically switch and choose any tokenizer in their library in a single line of code and automatically add it to our code. So it will figure it out where to look, okay, and then load it directly from their servers to our computers. The same goes for models. Now, as you noticed, when I type auto model and now I don't continue, you will see that there are so many options. Now, that's why you have that library that I just showed you before, their website, that allows you to look for models that you like. And I'm going to show you how to find out which code to write. So auto for image classification, for image segmentation, image to image, and so on and so on. So many different models that we can use. In this case, in particular, we just want to make our sentiment analysis works. That's it. And the first step that that pipeline worked for us is that tokenizer, or moving from these let me love for, from text to these kind of numbers. So that was done automatically, and that's something that we need to do that manually right now. Okay, so tokenizer is equal to auto tokenizer dot from pre-trained. Okay, and here we need to specify from where. Now there are many models that we can use, and I prepared one that actually works really well. And actually, let me copy and paste it to my from this screen to my screen, and then you can copy from chat. So let me copy this. Okay. Do you have any questions for me while I provide you with this? Okay. So let me open my chat and then just copy this. Oops. Okay. So here you are. Here you go. Use this, and to test it out, we can. Okay. Remove this line so we can Google it, and here it is, the first Hugging Face. Now, for any of these models, you will see immediately bits of code that you can use, like this. Okay, so all the models inside the Hugging Face already have an example for us. So let's say we want to go and use a text classification that we're going to use right now. And let's say we want, I don't know, Roberta, large. And I want that model, and here it is. Here is how to use it. Okay, so you have exactly examples of the code, how to include this model to our code. Now, for the code that I just gave you, I'm gonna continue with that one. So paste it right here and execute. Okay, it will take really fast, so nothing slow. This tokenizer will be responsible for us to take the text as a raw input and prepare it in this kind of a weird format, this one, that model will understand. Now, whenever we train a model, any company in the world, whenever we train a model, we are training it with these tokenizers, because these tokenizers are trained as well. And now the question, of course, is what they did trained on. Well, they're trained to recognize these indices. Okay, so it's not the same if you change this to 400, because suddenly every time that you have already changed something to 400 and you come to switch back, it's going to be I love car. Okay, and then you don't have exclamation mark, maybe you have something like you. Okay, So if you screw up this system of mapping from one to another, you will have something like this, which is not great, and your model performance will be poor. That's why you need a pair of tokenizer and the model. Model is really easy to do as well. So I'm going to use auto model for sequence classification dot from pre-trained, okay, and just copy the same name. That's how you know it's paired. You know the same name here, same name here. You can screw it up. Okay. Before we continue, let me see if you have any questions. We have Anna's question, so let me answer that, and please let me know if you followed along. So Anna asked, "Sorry, I missed the point. What are we trying to achieve in this project?" So we are right now working on um, basically building the understanding of the whole ecosystem of Hugging Face, and from the next labs onwards, we're gonna build separate projects and build our own models, basically, on different data sets and stuff like that. Yeah. So today we are gonna explore everything that you can do with Hugging Face. Okay. Yeah, you're welcome. So guys, have you managed to follow along with this? Let me know if I need to share back my screen so you can see my code. This is the code. Okay. Managed to import. Okay, amazing. Let me share back. Yeah, good. Okay, amazing. Thanks, Phil. I'll zoom out a bit so you can copy still while I continue. Now, let's write some sentence that's going to be our example. So you can write anything. And I do encourage you to write your own sentence so you don't have to follow along exactly what sentence I write, because this is going to be your personal kind of a take on this. So, for example, I love walking through the park with my two dogs. Okay? And now I want to show you what tokenizer actually do. So, tokenized text is equal to tokenizer text and return tensors pt. Okay? So, let's execute this, and what I just mentioned to you, this is what we get. Okay, return tensors pt is basically to return everything in a sense of readable output, basically, and probabilities. And as you can see, it prepared the text. So I was 0 in this case. Love is 100, walking is 657, and so on and so on. And these attention masks, you don't have to remember right now. So only these tensor, the first one, as input indices. So having trouble getting Colab to load the pre-trained model. Okay, let's see, William, what is the error that you're getting? Please try to reload your Google Colab. Okay. From pre-trained is not defined. Oh, okay. So you see this? Change the comma to dot. Auto tokenizer dot from pre-trained instead of comma dot print rate. There is a missing basically yeah, you just mistype. That's it. Nothing. Yeah. Please do try that, and I hope I know it's gonna work. Let me know if that solves. Yeah. It's a normal thing. Yeah. Cool. Amazing. Have you guys managed to type the rest? Have you got some? Of course. Um, have you? And thanks, Kundan. Sorry if I mispronounce your name. Um, please let me know if that if all of you actually followed along and got to prediction of the tokenizer right here. Yeah, nice. Okay, great. By the way, if you need to go to roll back to some part, let me know, and I can do that as well. Cool. Okay, so now we have our text, and it's time to make our predictions. Okay, so to make predictions, I'm going to add 2 more cells, just to have more. And the first step is to do outputs. And outputs are going to take my model, this model right here, and this to model, I need to provide my tokenized text. So if I do this, it's gonna throw an error. And why this error occurred? Well, because it didn't know which of these are actually input IDs or attention masks or whatever is out there that potentially some tokenizer in the world will recognize and put through. So to solve this, you can put these 2 dots, not 2 dots, 2 stars before, which will tell Python that take the names of your keys in this dictionary and use them as kind of argument names instead of using, for example, input IDs is equal to something. You can just put these 2 dots and it will solve the problem. And we have our outputs. And we made our predictions. Cool. Okay, so okay, cool. Return. Yeah, let me do that. So for Kundar, which line exactly? And hit refresh. You can see. Oh, okay. Yeah, tokenize call. So here it is. Return tensors equal to PT. Okay, and we got our outputs. Okay, line 18. Yeah, of course. So these outputs, if you just visualize them like this, you will see that we got two logits, basically, and we don't really know what those are. So logits are basically, sorry, logits are basically predictions of how likely something is. Now, in this case, we want to take and say labels is equal to negative and positive. Okay? This is our possible labels. Now, we want to take the highest prediction or highest value from this row. And to achieve that, you can use something called torch or numpy argmax. So torch argmax will return ID of that specific value that is the largest. And you can take that ID as an index, and you will see that it is positive. Okay? So here is how to achieve the final prediction that is readable to us humans. I love walking through, or I hate walking, sorry. And if I make predictions, and right now it's negative because I just changed love to hate, or vice versa. Good so far? Have you managed to make predictions with this model? Okay, cool. So I'll keep this here while I explain the next concept. Most popular, I would say, transformers and models, as we already talked about that, have their own tokenizers associated with them. And sometimes you don't really need to use auto tokenizer, but you want specific tokenizer in a world of, let's say, BERT models by Google. And that's something that they created the functions for. Loading not auto tokenizer that we used, which I used in 99% of the cases, auto tokenizer, but sometimes you can use pre-trained model for a specific task. So in this case, I can use from transformers. Let me check if there. What are we using? Okay, in front of tokenized text. Great question, Anna. So let me answer that question before we continue. So here, what we do is you have something in Python called quarks, basically, which mean keyword arguments. And when you define a function, oops, I don't know why caps is on. When you define a function like this, test function, you will have some inputs, let's say input IDs, and then maybe attention mask, and then maybe you will have model that is equal to none. Okay, traditional Python function. And then here I want to print out input IDs. And just to know that we are printing out input IDs. Okay, and let's do the same thing for attention mask. So attention mask, and that's it. We have our Python function. So now if I want to call this function, I need to provide these arguments. And of course, if I just want to call it, I'm going to get the error because say, oh, dude, you're missing 2 arguments. Sometimes, because this tokenized text is nothing more than dictionary in Python, it has 2 keys, oops, like this, inputs, input IDs, and attention masks. Okay? If I want to take these input keys and do like this, input IDs is equal to tokenized text of input IDs and attention mask is equal to tokenized text is like this. You see, it didn't let me make a one print in between so we can recognize. We provided it in a traditional sense as you would with any Python function. Now you can do that in here as well because this model function has input IDs and attention masks. But these quarks or keyword arguments means that if I do this and use tokenized text and just provide it, it's going to throw an error, of course. But if I put these 2 stars, Python will tell it, oh, dude, let me check the keys, the values from my dictionary and use input IDs and attention masks to populate these arguments from dictionary, basically. So you can put like this, and it will do the same thing as we did previously. Basically, that automated for us, and that's not in Hugging Space. That's not AI. It's basically Python work. Make sense? No, of course. Cool. So, okay, now from transformers, I'm gonna import another tokenizer called distill bird tokenizer. For today, this is just a name. We're going to talk about distilling, quantizing, and creating a smaller, bigger models in the future labs. That's going to be a really interesting thing on how to do that and why would somebody do that. For now, this distill bird is just a name of a model for us. Okay. So here I'm going to define tokenizer 2, which is going to be distill bird tokenizer from pre-trained, and here type distill bird base cased, and I'm going to copy this in chat so you can copy right from here. And when you execute this, you will create another tokenizer, but in this case it's going to be for a specific model called distill bird. So you can't go into any of these models that I just showed you in a Hugging Space and just use it, whatever. This is specifically designed for the distill bird. Now, why would somebody use this against auto version? Well, if you're using a specific model, this might be faster and more stable because you're not dependent on somebody else pushing the code and pushing the model. This is directly in the Hugging Face library, so you are always going to get the access to. In most cases, I'm still using the traditional auto tokenizer that we used before, but this is more for you to know that there is more possibility. Okay, so if I use some input text, that's going to be, let's say, Hugging Face is amazing, and oops, okay, and then output tokens, tokenizer 2 of input text. Again, we're going to get these tokens as we did before. These IDs are completely different because right now we have different tokenizer. As we talked about, every model, while it's trained, it does change the order of these words for its own tokenizer, which is a bit great for optimization, but sometimes it might confuse people and get different predictions. Yeah. Okay. So let's check. Have you managed to do this? All good so far? Okay. And to make just to demonstrate whatever we have in this tokenizer 2, I want to show you couple of different things, methods that we can use. So when I use this tokenizer dot, you will get a lot of different things that we can execute, of course, because it's kind of like a function for itself. So if I use just dot tokenize and put this input text, we're gonna get something called tokens. And these tokens are, in this case, not full words. And you might already know some model that is using the same thing. So let me copy this, and I'm gonna write OpenAI tokenizer. So OpenAI ChatGPT is actually using the same tokenizer, as you can see. Age, HUGING, face, is with a space, amazing, and then exclamation mark. Similar to us, we are doing the same thing. Instead of H, we are using HU, but the same concept applies. So we know we have the same tokenizer that OpenAI uses for ChatGPT 4 and 3.5 right here. Okay, amazing, huh? So with the same simple line of code, we achieve that. And that's something that OpenAI does whenever you press send to your prediction to ChatGPT, for example. It's parsing to these, and then you basically basically do that, and then make a prediction. Okay, no further question for now. Please let me know if you have any questions. Okay. So basically, that is something that that is something that we already have. Now I want to save this into tokens. Tokens 1 just to make a difference. And here we have something called tokenizer dot convert tokens to tokenizer 2 tokens to IDs. And this is something that we talked about. And let me just scroll back up. Here are the IDs. This is exactly what this is. So every word or a token has its own ID, 0, 1, 2, so on, 11, so on, 43, and like that. This basically just takes a look and checks, okay, so what is the order of these things? Okay, so that's basically it. Now, if I use IDs and save it here, I can go and write tokenizer tokenizer 2 dot decode and provide IDs. It will bring it back to Hugging Face. Cool. Yeah. So basically, that you see that it actually decodes to the original text that we have. Hugging Face is amazing. And we went from tokens, which are tokens one, then IDs like here, and then finally we brought back these IDs directly to Hugging Face is amazing exclamation mark. Okay. Oh, Yuri, no worries at all. Yeah, you will have the recording. Thank you so much for being here. Okay, so do you have any questions for me so far, or have you managed to follow along everything that we done? Okay, all good, amazing. Okay, so right now let's talk models. Auto models versus specialized. I misspelled it right here. Um, so as we had with our tokenizers, we have the same kind of a principle with models as well. You have specialized models, and then you have generated models with like yeah, from outside. So here I'm going to use from transformers. Okay, import auto model for sequence classification as we did before, and then distill BERT for sequence classification. Okay, so you can use both. However, auto model will have more flexibility that you will load additional models that are not distilled BERT. So let me show you this. If I go to our Hugging Face models and then you go to text classification, here you see how many models you have. Twitter Roberta, I don't know how to read this one. BGE re-ranker, BGE re-ranker base, code prediction, open assistant one, reward model, re-ranker, and so on and so on. Okay, so you have right here 55,000 models, and one of them is this one, Distill BERT. So Distill BERT is most popular one with, oh well, not the most popular, but really popular one. And this is actually like something that we're going to use. However, if you use this function called distill BERT for sequence classification, you can only load the distill BERT model, as you can see here. So if I just put distill BERT transformer with a sequence classification / regression head, and this one allows you, if I just select it, this is a generic model class with will instantiate one of the models. Okay, so we can load any of these 55,000 models. So depends on what you really like or want. So if I want to define a model, and I can use auto model for sequence classification from pre-trained, okay, I can write this down as we already have distill BERT base case. Okay, you have that in chat already, and I'm gonna copy this once again and just put distill BERT from sequence 2. And if I just execute this, both models will load equally. Okay, so and you will see that it will download only one model because it only takes one model. It doesn't matter which function you use, but basically it will load the still bird. Now, as I said, in 99% of the cases, I will use this one. And sometimes I would use this one if I want specialized model that I really, really know that I'm going to use. Let's see. Okay. Hi, Luca. I'm dropping as well. How to find... Okay, so we have a couple of questions, and then I'm going to continue. How to find the right model for my purpose from these... Are there any algorithm? Oleg, that's a great question. I'm going to circle back to that question in a bit. Let me go through two more questions, and then I'm going to answer that one. Hi, Luca. I'm dropping off as well. Somehow I'm not getting full resolution feed. Problem on my side, maybe due to mobile 5G. Hopefully, I will have it full resolution in recording. Thanks. Okay, so it's weird. I don't know why is that happening. Let me stop sharing my screen. Okay, you see my camera well? My camera is not blurry? Okay, so let me start sharing my screen again. Okay, is it still blurry, guys? Let me switch. Camera is good. Okay, let's switch to this. How do you see it's clear now? Screen share is blurry. Okay. Okay. I don't know. Sorry, guys. From my end, um, I can basically do only that. Right now, can you check if everything is okay? Let me zoom in, zoom out a bit to see if everything is okay. 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 So I don't have that information. Thanks. Oh, Joran. Oh, I don't know if I pronounced your name correctly. Uh, okay. Cool. So this basically showcases that we can load any model. Now, we had amazing question by Oleg on how to choose the model, and yeah, that's a great question. Okay, so let me go to my models. Any model always start by maybe most downloads, and you will see that some models are downloaded like 70 million times, 67 million times. And I will start from there and understand what this model does. It's not it's not big, so you can potentially deploy it. It has good documentation, so I would go from there. Always start from something that you can test it out, test multiple models, and always start from the most downloaded or trending or most likes. For example, this Finbird has most likes but only 1.4 million downloads. So all of the purposes and everything is explained right here. So for example, if I wanted to download this model, I can just copy this and go back to here. And for this auto model, I can paste it here. As you can see, it's downloading right now to my code. And I can test it out and compare to models. As you can see, bam, model downloaded right now. Okay. Do you see, is everything okay now? Yeah, of course. Creating and loading a model, like we are currently loading a model right now, any pre-trained model. Um, this is something that we are currently doing. And all of these models are trained on hundreds, if not thousands, of GPUs. So we don't have to. We can just load it into our code and just apply to our task, which is amazing. Now, you can fine tune the model and train it to your own data set. And that's something that we can do today as well. So I'm gonna show the data sets and how to train your own model and save it. Okay, so whenever you have a model, it can be a small model that will take a couple of megabytes of space, but then you have huge models that are gigabytes, if not terabytes of space. Well, terabytes are rare models, but in most cases, it's going to be tens, if not hundreds of gigabytes. So, whenever you have those big models, we are not the ones that are going to be training them. Well, maybe some of you, yes, in the future, why not? But in most cases, we're going to rely on Hugging Face that already has these models trained. Because, for example, this model right now, Process AI, is a company. We can explore what they do. They train this model, Finbert, for analyzing financial text. And they invested their time and money to train this Finbert model. Now, you have these big companies or just general companies that train this model, prepare them, and then put them on the Hugging Face so we can just import in a single line of code like this, and then start performing and doing some things with it. However, you want to sometimes optimize these models to work on your data. Let's say that, let's bring this back to the Stillbird. And I want this model to work on IMDb dataset. So IMDb dataset is dataset for movies, basically. And it's a review about a movie. So is it a positive or negative or neutral and stuff like that. And I want this Distillbird model to actually work on that IMDb dataset. Okay. So now, this is a toy data set for today's lesson. In the future labs, we're going to actually use real data sets that are much, much bigger and train our own models for projects that you can put on Hugging Face space, and have a portfolio project for you. Uh, okay, can you hear me? Yeah, yeah, yeah. So Phil asked, can we actually uh, train and then put a model to a Hugging Face? Absolutely. Like, it's free. Like, the same goes for any, like, GitHub, for example, account. You would create your own GitHub account and put your projects. The same goes for these models. You can train in Google Colab, that we're going to do today, and then basically put that on the uh, Hugging Face. And that's how you're going to build your own portfolio. Now you can later put that inside of your LinkedIn or resumes and stuff like that, and then build from there. So whenever you want to train, now this part is a bit more tricky. So we're going to start building it, and hopefully to finish today. It won't be as difficult as yeah, it might be a bit tricky to finish it today. So let's focus on a couple of more questions, and then train the full model on the new data set the next week or the next lab that we have, and then push it there. So the next lab is how to train your own model. But before we do that, let me show you how easy it is to download the data set and use it. So datasets is a library under Hugging Face, and it has 130,000 unique data sets. Now, all of these are like from text, images, optimization problems like reinforcement learning, robotics, all sorts of stuff. Like, for example, this is for robotics. Now, this to load the dataset is as simple as loading a model. So from datasets, import, load dataset. That's it. And dataset is equal to load dataset with a certain name. Let's say IMDb, and you have data set. So dataset will be downloaded directly to your page, and it's already split up to train, test, and unsupervised in this case. How amazing is that? So we already have pre-trained data sets, prepared data sets. And to Phil, I think, asked the question. Okay, Paul, thanks for being here with us. You can create your own data set and push it to the Hugging Face as well. So the next time we train our model on any data set that we're going to choose together, and then we can, on top of that, create our own data sets from any images or data source that we find and push it there. And that can be also your portfolio, like creating data sets for different use cases and different data sources that you might be unique in. Let's do a couple of operations with data set to see how easy it is, and then we'll leave the training time for the next week. So it's really easy to take, for example, data set, and then take, for example, train, and it will take only the train library right here. Now, in most cases, you will need some. These data sets are raw data sets. What that means is, if we're talking about text, you see it's a text. Now, if you want to create and map out, let's say, a tokenizer to process the whole thing, you can. And this map function is from Python that will apply the same operation to all 25,000, in this case, 25,000 reviews for movies. And to achieve that, I'm going to use lambda function, sample. You can put here whatever you want. I put sample, you can name it whatever. And this is where we're going to call tokenizer 2, maybe. And then sample of here text. Okay, so I'm calling tokenizer, and this tokenizer, we can leave it as it for now, and then I'm going to explain what else we can do with this. Then we're going to provide batched equal to true, and then batch size is equal to 16, 32, and so on. So what this does is actually takes all the complexity and process the whole data set for us. So first of all, for any sample, we're going to take tokenizer, apply tokenizer. That means that we're going to take and convert it to this, okay, from pure text. And not only that, but we're going to prepare it so we can train on batches, meaning we're not going to put all 25,000 samples immediately to the model, but we're going to do it step by step, 16 by 16 samples to the data set. Now let me pause it right now and see if we have any questions. Okay, so right here you can put two more arguments, which is padding and truncation. Padding is equal to true and truncation is equal to true as well. Now, these two might be so weird for you. So let me explain in a visual sense. Whenever you have models, you might have, let's say, 16 sentences. I love this car. I am an AI engineer working at Google. I live here. Okay. And you will see that these three sentences have different amount of words. This one has 1, 2, 3, 4, and if we count, let's remove exclamation mark and dots and just leave words. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3. Models, as good as they are so stupid. We need to tell them what is the longest and what is the shortest sequence they can accept. So we can say, hey, max is 5, let's say 5 words, okay, min, or just max is 5 words, okay. So what happens in here, because this one has 4 words, we're gonna have padding, okay, or just pad like this here, because it needs to be 5, because it should be 5. And this one has 3 words, so we're going to have 2 of these pad words or tokens or whatever we call them. However, this one, what I just showed you, is called padding. Now, adding some arbitrary word, so it becomes some length. In this case, it's 5. Now, truncation is meaning I am an AI engineer working at Google, have more than 5 words. So what's going to happen is I 1, 2, 3, 4, 5, remove the rest. Okay. And here we have all sentences being 5 words each. And this one, these two arguments, will help you achieve this. In most cases, in like 95% of the cases, I would use padding and truncation to true. Okay. So please, let's see, copy this and start processing the dataset yourself. Let me know if you're done, and I'm going to bring back to share screen so you can copy. Okay? Have you managed to copy, guys? Great. Having connection issues, I'll try later. Oh, okay. Phil. Okay, cool. Please let me know after the recording if you still have problems and you are not managing to connect in the comments. I'll monitor the comments and let you know if I can help you. Like, yeah. So basically, this is how you prepare your data set. Now, as you saw, we just loaded an arbitrary data set, but there are 130,000 of unique data sets that we can use and play with and build additional models and stuff like that that will actually like create great value for us and our customers. And the only like kind of a processing that we need to do is this. So create a tokenizer, tokenize that in and use these two tokens to achieve this, and we are basically done. So for the home exercise, do the same thing for testing dataset. So instead of this, you switch to test and then try to do that. And that's basically what's going to prepare you to train your own models. We're training the models. We require some more installation and some guidance because Google Colab does have some restrictions because of GPUs. So that's going to require additional our time to explain. That's why we're going to leave it to the next lab. So that's it for today. I will stay to answer all of your questions that you might have. And I'm interested in knowing how do you like Hugging Face so far. Please let me know all your comments, what you like, what you don't like, what was the hardest part. Should I explain something differently? And yeah, let me know while we're on the call. The next lab will be training our own model and putting that on Hugging Face and creating the first project for portfolio. So we're gonna train our models for different use cases, text classification, image to video, text to image segmentation, and prepare the data set and then train the model to understand what it goes to train these big models and creating your own portfolio. And then portfolio is really easy to share because let's say, for example, recently created, we're gonna take like this Jake created 1 minute ago. See, readme file does not exist, but it does have files. Let's take something else that was created recently created, and let's use that, maybe this one. And it created doc strings for Python, and you can see these are the files. So we're gonna upload the files right here, and that's something that we're gonna do the next week. Not next week, next lab. So you can, basically upload and create your own first project that will look something like this. Everybody will be able to see your models, probably your data sets. You'll create your own profile with the image if you want, of course, and then you can share this profile with your colleagues, social media, and stuff like that.
Now make sure to check out these videos on the right or the full course in the description to continue your learning, and I look forward to seeing you there.